Good morning, kids. Welcome back. This is Nagarjun Reddy. I will be handling the course of Power System Operation and Control for your next semester. This is an introductory video where I will be discussing the aim of this course, the learning objectives, and the course outcomes of this particular course. Also, at the end, I'll be giving you a brief information of assessments and my expectations. Coming to the aim of this course, as you all know, being the power engineers, it is always a complex problem for us of how to understand this power system, how load is being shared on different generators which are available for us, how load is shared on the transmission lines which are transmitting the power, and how the system is maintaining its stability. So these are all the complex problems which we are supposed to understand and have a solution. So this particular course is aimed at introducing you the elementary concepts of the power flow, the computation of power flow, the economic load sharing between the generators, and how the stability of the power system is determined. So we will be covering all these concepts of power sharing, electric power sharing among the transmission lines, among the generators, and understanding the stability of the system. This particular course is divided into 4 units. Each particular unit is having its own learning objective. We will see these are the 4 learning objectives of the 4 units which you will be having in this particular course. The first one being the computation of load flows in the power system by employing various iterative methods which you have studied in your mathematics. The second objective is how to control the reactive power in the power system. As you all know, the transmission lines do carry the reactive power in the power system. So we will be discussing about various methods how this reactive power is going to be controlled and how to improve the overall efficiency of the system. And also we will be discussing about the process of distribution of load among various plants and generators in the plants in your unit number 2. In unit number 3, we will discuss about this concept of load frequency control and how to analyze it in an isolated power system and also in a 2-area power system. And lastly, we will come across this concept of stability and what are the different types of stability and what are the factors which do affect the stability and how to improve the stability of the power system. And coming to the contents, unit-wise contents, has already been said, Unit 1 aims at understanding the load flows, how much load is being flowing in a particular transmission line. So the major contents of this unit number 1 are, we'll start with what is the significance of this load flows, why we must study these load flows, and what do you understand by the concept of buses, how the buses or what you call it as nodes in the power system are classified, and we will discuss about the incidence and network matrices which present the geometric structure of the network. And next we will move on to the load flow computations, the basic algorithms which do help us in determining the load flows, and we'll employ different iterative methods for solving the load flow problems. The list of the methods has been shown there, the Gauss method, Gauss-Seidel method, Newton-Raphson, and advancements of Newton-Raphson method like decoupled and fast decoupled method. We will employ all these methods to finally get a solution or finally compute the load flows. And unit number 2 has two parts. Part A is about the PQ control, mainly aimed at controlling the reactive power in the power system. We'll start with what is the need for reactive power compensation and the various devices which are normally employed for controlling the reactive power in the power system. We'll come across the excitation of the synchronous machine, the capacitor banks, the transformers, different types of transformers like the tap changing transformer, booster transformer, etc. And also we'll come across these VAR compensators, which are now extensively used to control the power flow in the transmission system. The second part of unit 2 is about economic operation of power systems, which deals with how to share or how to distribute the power generation among the various units which are available to you, so that the total cost of the generation is minimized. So we'll come across the load sharing between the generators in a particular plant, and we also come across the load sharing between the plants when you do have a number of plants in purpose. So also we will determine the transmission losses using B coefficients. We will see overall how we can operate the power system economically, how we can distribute the power generation economically. Unit number 3 is about load frequency control. As you all know, the biggest problem and the biggest challenge in the power systems is maintaining its frequency. In India, we are supposed to maintain the frequency at 50 Hz. This is one of the biggest challenges in the recent past, because right now all the industries and even the satellites or even the clocks are completely digitalized. So we need to maintain the system frequency at 50 Hz. Even a minute change in the frequency will lead to huge losses in the country's growth and the country's income. So why this frequency? Why the changes in frequency are impacting, and how the changes in frequency are impacting the system? So we will start with this: what is the need for maintaining this frequency constant? And we will see the various parts of this isolated power system, how the frequency is changed and what are the factors which do affect the frequency. And we will try to develop a model, mathematical model of the biggest influencer of frequency. As we all know, the load is a primary influence which influences the system frequency. So we will develop a mathematical model of change in frequency with respect to the change in power for an isolated power system, and also we will develop a mathematical model for a two-area system. And thereby we will try to understand the load sharing between the generators so as to maintain the system frequency. And in the unit number 4, I'll try to introduce you with the basic concepts of stability, the classification of stability, and particularly we will be concentrating on the transient stability and the swing equation, trying to understand the dynamics of the machines, the swing equation, the critical clearing angle and critical clearing time, two important terms in the power system stability, and the factors which do affect this transient stability and also steady state stability, and the methods to improve the stability limits. So we will come across all these terms. These terms may be new for you, but in the due course you will get familiar with these all terms. So I hope by the end of this unit, by the completion of these 4 units, you will be able to compute the bus variables and the power flows in the power system and hence the power losses in the system by the end of unit 1. And by the end of unit 2, I hope you will be getting familiarized with the different methods of reactive power, and you will be able to compare them, employ them in your application, and also determine the optimal economic load scheduling. By the end of unit number 3, I hope you will be able to determine the frequency response of a single area and two area systems and improve it with suitable controllers. And last, by the end of the unit 4, I hope you can predict the stability of the power system, or you can analyze the power system stability by using a mathematical model which is capable of describing the electromechanical dynamics of the power system. And I hope you will be able to determine the transient stability limits also. So these are the textbooks which I'll be following. I do suggest these textbooks for you also. The first one being the Modern Power System Analysis, the 4th edition, which is being imprinted by the Tata McGraw-Hill Education Private Limited. It is written by well-known authors, Nagaratha sir and Kothari sir. The other one is C.L. Vadva, Electrical Power Systems. So you will get the entire material in these 2 textbooks. I do prefer that you do follow these 2 textbooks. And if you do have any doubts, you can go to the advanced reference books, Power System Analysis by Stevenson. And there is another book, Power System Analysis, Operation and Control by Chakrabarti. And if you are still interested, you can go with the online Swayam MOOC course, which is dealt by Professor Debapriya Das. I have already completed that course, and I felt that it is one of the good courses which I have seen in the recent past. It is a 12-week course which is to be offered this upcoming semester. And coming to the assessment and grading of this particular course, there will be 8 assignments. As per your curriculum states, there must be 8 assignments, 2 per each unit, and there will be 2 mid-exams, each one of 25 marks, and there will be an end semester examination. But to improvise your learning and to have a free hand at assessment and grading, I would like to go with, since our classwork is aimed at 12 to 14 weeks, so I would like to introduce a weekly assignment for you, and the average of all these assignments will be considered as your assignment score at the maximum of 15 marks. And my expectations on you is, I hope that you will be attending each class. I'll try to take class role in each of the sessions. I do expect that you do read the recommended textbooks. The first one primarily, the Modern Power System Analysis by Nagaratha and Kothari. And I hope you work all the assignments and submit them before the due dates. Thank you, and wish you happy learning.